NASA, the National Aeronautics and Space Administration, presents Aeronautics and Space Report.
A lunar landing over the Virginia countryside. Not really, but recently astronauts practiced making moon landings at NASA's Langley Research Center, Hampton, Virginia. It's called the Lunar Landing Research Facility and consists of a giant structure 400 feet long and 250 feet high. It is so designed that an astronaut can maneuver in a cab similar to the lunar module, experiencing the same 1/6 gravity of the moon. The rocket-powered vehicle is supported by cables and travels on rails at the top of a gantry-type structure. One of the men taking part in this training was astronaut James McDivitt, command pilot for an upcoming Apollo mission. He described the purpose of the tests.
The Lunar Landing Research Facility here in Langley does just what its name implies. It looks at the lunar landing problem and does the research necessary to establish a certain set of acceptable techniques for landing on the moon. My particular training here is in conjunction with the normal training that all the astronauts get. It does not apply specifically to the flight that we'll be flying. However, I would like to point out that there are certain limitations that we're faced with in trying to get to the moon. And that is that we can't do all the operations in flight that we'll have to do prior to the time we land at the moon. And the practice landing is a prime example of this. Here at Langley, we're running through the techniques that we're going to need when we get there. So we're examining one facet of the flight here at Langley. On our mission, we're going to examine the orbital facets of the flight, and we'll try to bring all these things together so that when we go to the moon, we'll have a good idea how they're all going to fit together and what we can really do before we get there.
Hydroplaning, a phenomenon causing tires to skim along a runway like water skis. It can also happen to your car. For several years, NASA has been studying hydroplaning. Special test areas like this landing loads track have helped engineers determine the problems associated with landing under various runway conditions. It has been found, for instance, that by cutting grooves in runways and highways to allow the water to run off, a pilot or driver has better control. Already more than a half-dozen airports around the country have grooved runways. To find out how effective runway grooving is, this big 990 jet has made landing after landing on various runway surfaces, ranging from water-soaked to those covered with slush and ice. Recently at Wallops Island, Virginia, NASA engineers began a series of tests to come up with a system for predicting how aircraft brakes will perform on wet or slushy runways before landing. A system which could be applied to highways as well. The testers were joined by many other government and industry people interested in skid research. A future system might work like this. A specially equipped car would drive down an airport runway at approximately the landing speed of an incoming plane. Its recording devices would show if the plane could land safely without skidding. A similarly equipped test car could also give highway officials more effective advance notice of skidding conditions. Right now, data from both the airplane and automobile tests are being correlated. The results may one day make airport runways and highways safer.
This has been an Aeronautics and Space Report presented by NASA, the National Aeronautics and Space Administration.